Time to do number 3 on the free fall set, which is where a ball is thrown straight up and it returns to the thrower's hand. Again, starting with a picture. Here's our start point. It was thrown straight up. It goes up and comes back down. Now, it would come down the same path, but it's harder to see what's going on. So there's our start and our end point. Now, in this case, we have an object going up and going down. From the previous two problems, we saw that when we saw the object was initially thrown up, we called positive y up. When everything was going down, we called positive y down. We have a choice in this case to make. We only get one axis. I am going to choose y up. When I have a choice, I'd like to choose positive as the direction of the initial velocity. So based on that, let's set up our list. So we were given the time as 2.88 seconds. Now there is one acceleration, not one on the way up and not one on the way down. We go with what our axis says. So A is negative g, negative 9.80 meters per second squared, since once again, g always points down and it's opposite to our axis. The key to this problem is looking at one thing, which is delta y. Delta y in this case is 0. Remember, delta y is displacement. It started and stopped at the same point. And what we are looking for is v0. The other things are v and v bar. So let's set up an equation. We have one. Delta y equals v0t plus 1/2 at squared. Since delta y is 0, we can then solve this for v0. v0 is negative 1/2 at squared over t, which is negative 1/2 at. Again, you have to make sure you know your algebra. And now we can substitute in v0, negative 1/2, negative 9.80 meters per second squared, 2.88 seconds, and we end up with a positive 14.1 meters per second, which seems reasonable given the problem, and it agrees with our axis. We called y up, the initial velocity is up, so they should both be positive.